Before you is a snapshot taken by the Hubble telescope. The brightest spot is the galaxy called Arc of Solar Rays, or PSZ1 G311 65 1848. The second brightest spot in the photo is the same galaxy, as well as the third, fourth, fifth. All 12 spots are the same galaxy. It seems that a cosmic Xerox has appeared in the universe. Where did 12 copies of the same galaxy come from in space? And how many more fake duplicates do we see? Let's first try to illuminate the night sky with a flashlight. You will be surprised if you see that a beam of light directed straight into space will not fall back. Just the phrase that light will fall on Earth sounds strange. In earthly conditions, rays do not fall. Light quanta, at their enormous speed, can freely move in a straight line in space and will try to leave the Earth's surface behind. But in space, there are many other objects capable of changing the straight trajectory of light with their gravity. Some of them, like black holes, completely absorb any radiation, and others are capable of significantly distorting the flow of light. Imagine that a lantern outside the window prevents you from sleeping at night because it blinds your eyes. But you get up, open the window, and with your hand, push the beam of light aside. Fantastic, of course. But on the scale of galaxies, everything happens approximately like this. Massive bodies distort the rays of light and indeed decide to correct the light. Therefore, they increase their intensity far behind themselves. The distance between Earth and a galaxy, spread over 12 copies, is quite large, 11 billion light-years. But the most important thing is that this vast space is not empty at all. It is filled with clusters of galaxies so massive that they are capable of changing the trajectory of light with their gravitational field. But the speed of photons is sufficient so that the beam does not fall under the influence of gravity. To an external observer, it will seem that the light only bends towards the massive object, or conversely, bends away from it. In physics, this is called gravitational lensing. Its essence lies in the fact that huge, massive objects can bend electromagnetic radiation, just like regular lenses do with light rays. Only unlike optical, gravitational lensing works a little differently. It distorts the light more that passes closer to the center of the object, and affects less the rays that are located further from it. In the case of an arc of solar rays galaxy, through the lensing effect, the light bent immediately in some directions. 4 main arcs appeared, 3 in the top right corner, and 1 in the bottom left corner of the photograph. Thanks to these arcs, scientists on Earth can see 12 light copies of a single galaxy. Many of these copies are 10 to 30 times brighter than the original itself. The galaxy itself is quite dim, which made its study difficult. But thanks to the copies, it is possible to observe inside it an object only 520 light-years in size, which is very small on the scale of the universe. This is 203 times smaller than the diameter of the Milky Way. The arc of sunbeams is the brightest galaxy experiencing gravitational lensing, but it is far from being the only one, because as of the year 2021, astronomers have already discovered about 1,500 gravitational lenses. That is, if right now you take a telescope and look into the night sky, you can see many copies of distant objects. But for a galaxy to act as a gravitational lens, its mass must be at least 3 trillion times the mass of the Sun. Although for stars, this figure is much smaller. Our Milky Way galaxy is just right for such purposes. Its total mass reaches approximately 1.5 trillion solar masses. This means that any object outside our galaxy will appear split into several copies to Earth telescopes. But who needs telescopes there? Sometimes you can see everything even with the naked eye. When you look at the starry sky at night, most often you come across not the original, but a copy. This was proven by the experiment of the English physicist Arthur Eddington, who made it with his colleague, Albert Einstein, incredibly popular. As early as 1919, Eddington decided to test Einstein's theory that large objects distort space. While observing a solar eclipse on the island of Principe, Eddington noticed that the light from the star, which was near the sun, is actually distorted and follows a slightly different trajectory. In other words, the star itself was not in that place where the scientists discovered its light. Thus, all of Einstein's predictions were confirmed, bringing him worldwide fame. To this day, two methods of gravitational lensing are known: the Einstein ring and cross. If light from a distant object passes through a compact galaxy located along the same line between Earth and the light source, then for the observer, the object visually enlarges and transforms from a point into a ring. However, if the light passes, for example, through a spiral galaxy, then we will see Einstein's cross. In the center of this image, you can notice a spiral galaxy, which acts as a lens, and the four dots around it are four copies of a single quasar located behind the lens galaxy. There is also a fifth copy, but it is practically invisible, and altogether, including the galaxy itself and the quasar, form the gravitational lens G2237 plus 0305. The light source, namely the quasar itself, is located at a distance of 8 billion light-years from us, while the galaxy acting as the lens is located 20 times closer, only 400 million light-years away from Earth. In turn, the Chumak path is also spiral and not a spiral galaxy. Therefore, passing through it, light rays are deflected and create an image of Christ. Some other large objects fall slightly short of massive gravitational lenses, so they can cause exclusively microlensing. In this case, light copies are not formed. Only short-lived flashes are formed, which are recorded with special devices, or they may remain completely unnoticed. The existence of gravitational lenses confirms the general theory of relativity, according to which not only light is distorted, but also space and time themselves. Einstein was the first to start talking about space-time as a kind of fabric, and any matter, including supermassive galaxies, black holes, stars, and planets, distort it. This is precisely why gravity works. Try it. Try pulling any fabric tightly and placing a heavy object on it. Then throw a ping-pong ball there, and it will start spinning around the heavy center along the folds of the surface, or it will roll down immediately. It depends on the ratio of their masses. The same thing happens on a large scale. The moon is constantly falling towards Earth along the curved lines of space-time. Earth falls towards the sun, and the solar system towards the center of the galaxy. Since time is closely related to space, it also warps around large objects. The closer you are to a massive object, the slower time passes. Near a black hole, it can actually stop, while in open space, on the contrary, it can accelerate. But probably the most important advantage of gravitational lenses is that, exclusively thanks to overmassive galaxies that distort light, we can observe faint, distant objects. So far, this is the only possible way to do it. Even our sun, despite its relatively small mass, can also be a gravitational lens. With the help of our star, it was possible to observe objects of planetary sizes, which are located at a distance of 100 light-years from Earth. As claimed by the Italian physicist Lorenzo Maccone, the ability of the sun to distort the light of distant objects allows to obtain more detailed images than thousands of telescopes combined could provide. Quite likely, if you look at the solar system from a distance of several million light years, you can also see its copies. What do you think? If extraterrestrial civilizations exist, could they find us by orienting themselves by the light copies of the solar system? Write in the comments. If you liked my video, subscribe to the channel. Click on the bell so you don't miss new releases. Also, give a thumbs up and share this video with your friends.